and good day, Algebra. We are going, continuing CO41, which is solving a system of equations using substitution. We're on part 2, which you can see is a whole bunch of words. And the beauty of part 2 is that now you get to set up the system yourself. Okay. Now, who remembers what makes a system? Like, in order to have a system of the equations, what do you need? How many variables are you solving for? 2. How many equations do you need to have? 2. Okay? So 2 equations with 2 variables to solve for. That's what we need to kind of pull out from these word problem situations here. Okay? And there's a method here. All right? I very much encourage you to write down all of the notes here. Don't skip any steps. Because when you start to do these on your own, you're going to want to look back at examples, right? And if there are things that you didn't write down, you're not going to have those steps to help you when you start to do it yourself, okay? So it says you burn 8 calories per minute shoveling snow and 10 calories per minute throwing snowballs at your friends for a total of 560 calories burned in 60 minutes. How many minutes did you spend doing each activity? Okay? The first thing we want to look for here is we want to identify our variables. What are we solving for? Okay? Because each equation is going to need to contain 2 variables. And we have to know what those variables are if we're going to write an equation about them. And normally, where you can find what you're solving for is in the question. The question here says, how many minutes did you spend doing each activity? What are the 2 activities that it's referring to here? Throwing snowballs. Okay, so we'll use we'll use T, which is going to represent our how long we throw snowballs. So we'll say minutes throwing. Right? And what other variables should we use here? What other activity is being done here? You might be doing a lot of this over the next 3 days or so. Sophie. Shoveling snow. And my S's are notorious for looking like 5s, so I'll try really, really hard. That's a good S there. Okay, and that is minutes shoveling. Be careful not to throw out your back. Okay, so that's what we're solving for. The number of minutes we are throwing snow and the number of minutes we are shoveling snow. Right? Task number 1 complete. We've identified variables. The second thing is we need to identify our totals, right? Because equations have to equal something. Okay, so looking at the situation, what are the 2 totals, 2 equations, 2 totals that our equations are going to have to equal? Not going to be 10 and 60, because the 10 calories is kind of with that throwing snowballs. But the 60 is, okay, one of them is 60. And that 60 is in minutes. We'll talk about why it's important to pay attention to units shortly here. But the 60 is in minutes. The other total, Haley? 560, and that unit is calories. Right? So, one equation is going to equal 60, and the other equation is going to equal 560. Let's start with the one that equals 60. Now, the 60 refers to the number of minutes that we're doing these 2 activities, right? We spend some amount of time throwing snowballs, some amount of time shoveling snow for a total of 60 minutes. What equation is going to represent that? That the number of minutes shoveling snow plus the number of minutes throwing snow will equal 60 minutes total. Any thoughts?
T plus X equals 60.
Excellent. Yeah. T plus S equals 60. Right? Because however many minutes we spend throwing snow and however many minutes we spend shoveling, we add those together, we get 60 minutes total. Okay? And remember, the thing about a system is that it's not enough just to have this equation and solve it. I mean, T could be 40 S could be 20, T could be 30, S could be 30, T could be 59, S could be 1, right? We need that second equation to get more information about this because there's a lot of different things that could be for T and be for S here to get them to add to be 60. So the second equation equals 560. This has to do with calories, right? 560 calories. And the units can be a hint as far as what the equation is going to look like, because if 560 calories is the equation, we want to look at our 8 calories and our 10 calories, right? Those units match. So this one's going to be something with that 8 and that 10. It says 8 calories per minute shoveling snow, 10 calories per minute throwing snow. What expression represents 8 calories per minute shoveling? Remember, minute shoveling is S, right? Burning 8 calories per minute shoveling. What expression is going to represent how many calories? Yeah.
T plus 8.
Not T plus 8. No.
S times 8.
Right. 8 times S, or S times 8. We're going to write it as 8S because that's how we're used to seeing it here. But 8 calories per minute shoveling. I'm looking backwards too. It's an S, people. It's an S. Okay. But 8 calories per minute shoveling. What's the 10 calories per minute throwing going to look like? What expression is going to represent that, or what term? I bet a lot of people are thinking it.
10x.
Not 10S, but 10T, right? 10 calories per minute throwing plus 8 calories per minute shoveling equals 560 total calories. Okay? Yeah.
Does it matter like which one's on like it?
It does not matter the order. You could write S plus T. You could put T plus S and then 8S plus 10T. I kept them lined up just for the seeing it, but no, it does not make a difference what term comes first. Okay? But now we've got the system. You've solved this before, right? T plus S is just like X plus Y. 10T plus 8S would be like 10X plus 8 Y. You've solved this before. And that's why the process of CO41 part 1 is so important. It comes back into play here. But again, setting these equations up. Step 1, variables. What are we solving for? Right? And each equation has a T and an S in it here. Step 2, our totals. What do our equations equal? One of them equals 60. The other one equals 560. Minutes, calories. Okay? Minutes throwing plus minutes shoveling equals 60 minutes total. 10 calories per minute throwing plus 8 calories per minute shoveling equals 560 calories total. Where would you go from here to solve this now? Move it over. Okay? You want to isolate T or isolate S? It doesn't make a difference. Let's just, to be consistent, who would like to, that maybe you've already started solving this and want to make sure that we do the same work. What would you like to isolate? You want to get T by itself or S by itself?
T.
T? S?
S.
Okay. Well, if we get T by itself, we might spill it. So we don't want to do that. So we'll get S by itself here. Okay. Again, S by itself means you move that T variable over. So this equation is going to become S equals negative T plus 60. There's that sign change again, right? That came up in the homework check twice. We're moving the T variable over to get S by itself. And so when you do that, the sign of that T changes. Okay, because we're subtracting T from both sides. So S equals negative T plus 60. Now, what do we do? Now that we've isolated S, what's our next step?
Put S in the equation.
Right, take this, if S is equal to negative T plus 60, we're going to replace S in the second equation with negative T plus 60. So that becomes 10T plus 8, but instead of S, we're substituting in this new expression, negative T plus 60, and that equals 560. The 10T stayed the same, the 8 stayed the same, The 560 stayed the same. The only thing that's different is we substituted negative t plus 60 in for s. And now, you've heard me say this before, we have one equation with one variable to solve for. Jack, yes?
Can I be excused from the homework check?
The bell ringer?
Yeah.
We can talk after class.
Alright.
Okay. Now it kind of brings in vibes of PO7. You know, you distribute first. 8 goes into the parentheses. 10t plus 8 times negative t is a negative 8t. So I'll put minus. So 10t minus 8t. 8 times 60 is 480. And that equals 560. After we distribute, combine like terms, yeah.
Wait, in the first equation up with the 10t plus, is that 8s?
Yes.
Okay.
I'm sorry, my S has never been great at it. 10t minus 8t is 2t, right? Combine those like terms. 2t plus 480 equals 560. Hopefully you've got some more space to write. I'm going to take this and bring it up here. 2t plus 480 equals 560. Subtract 480 from both sides. That gives us 2t equals 80. Divide both sides by 2. And we spend 40 minutes throwing snowballs. Which means if we spend 40 minutes throwing snowballs, how long did we spend shoveling? 20, right? Because t plus s has to equal 60. If we plug in 40 into here, that means the s has got to be 20. So t equals 40 and s equals 20. Woo! It's a lot of steps. Okay? Everything from here down, you've done before, right? That's all from part 1 here. Not saying that you have mastered it, but at least you've done it before. You get something to look back on. Really, the new challenge here is setting those equations up. And this is kind of the thought process behind it. What are the variables? What are the totals? Okay? Questions on this? Jeffrey.
Right after you're distributing, why does it go from 10t plus 8 to 10t minus 8?
Because an 8 times a negative t is a negative 8t. Ellie. The 10 here?
Yeah.
So the 10 calories per minute throwing, that's kind of that's an expression there, right? 10 calories per minute throwing. If our minutes throwing is represented by the variable t, and you burn 10 calories per minute throwing, remember this word per means that you're multiplying, right? Minutes throwing is our variable t, that's what we've assigned it here. And then 10 times t. You know, if you spend 2 minutes throwing snow, you burn 20 calories, right? If you spend 4 minutes throwing snow, you burn 40 calories. You're going to take whatever t is and multiply by 10 to get the number of calories burned. So the 10 came from this phrase here, 10 calories per minute throwing. Now we got 10 times. And we can check this, right? If t equals 40 and s equals 20, we go to this equation here, that 10t plus 8s. 10 times 40, which is our value for t, plus 8 times 20, which is our value for s. Well, 400 plus 160, that does equal 560, right? We can check it and make sure it works. The nice part about word problems, though, for specific lab, is that your answers have to make sense in the context. Would it make sense to get a negative answer here for S or for T? Can you spend a negative amount of time doing something? No. So if you got like negative 10 as a value for S or a value for T, then you would know that you did something wrong. And you want to go back and take a look at it. Okay? That's a nice part about that there. Anything else? Okay. Oh, yeah. We'll go through another one. Sure. Jack.
But what if you're eating while shoveling?
So what we're solving for is the minutes shoveling and the minutes throwing,
Oh.
right? So it's the time that you spend doing something.
Oh.
You can't have a negative time.
Okay.
All right. Next one. The members of an outing club take a day-long tubing trip down a river. The company that offers the tubing trip charges $15 to rent a tube for a person and $7.50 to rent a cooler tube, which has nothing to do with social status. It's carry food and water in a cooler. Okay. The club members spend $360 to rent a total of 26 tubes. How many of each type of tube do they rent? Step one. What are we solving for? Look at the question. How many of each type of tube do they rent? Go ahead and see if you can identify. Write down, what are we solving for? What are the variables of our equations going to be? And there are two of them. Okay? Jack, don't do that. Who's confident that they have an idea what we're solving for? Jay?
For the variables, I did T for how many tubes and C for the cooler.
Okay. So the each type of tube, how many types of tubes are there here? Two, right? One is a tube for a cooler, the other is a tube for a person, right? So you're close, Shay. Yeah, it's the not the number of tubes total for one variable, it's each type of tube. And so we'll use P for a person tube, and we'll use C for a cooler tube. Both are types of tubes. One's just big enough for a person, the other one is small enough for a cooler. Okay? Yeah, Jack.
Do you have any pencils?
I do not. Sorry. I only got a pen. Would you like a pen?
Sure.
Black, okay?
Yeah.
There you are.
It's hot.
Okay? Step two now is to identify totals. Right? What are our equations going to equal? Again, if you read the question, you can usually pick out the word total, or you can see kind of what the grand value is here. Yeah?
15.
15 is not a total. That's how much
26.
one type of tube. 26 is a total, right? And 26 refers to
360.
the number of tubes. Okay. Our other total, Liam?
360.
360. And what unit is that? Money. Dollars. Okay. Oftentimes, and I'll say this again when we go over a future one here, in a substitution type question, if you're dealing with money, you're going to have one equation that refers to quantity, how many tubes, the quantity, and one equation that refers to the value, how much does each tube cost or worth or whatever. And that's what we have here, right? Our tubes equation is how many tubes, the quantity equation. Our second equation, the 360, that's our value equation. Okay? How much money is being spent or whatever here. All right? Jeffrey, you got 5 minutes left. Can you wait? Okay. So, 26 total tubes. How can we use our variables of P, person tube, C, cooler tube, to write an equation that represents the quantity of tubes purchased? P plus C. Very similar to our first one, right? The number of person tubes plus the number of cooler tubes equals 26 tubes total. Okay, P plus C. That's our quantity, the number of. Our second equation now has to do with the dollars, cost. $15 to rent a person tube, $7.50 to rent a cooler tube. How are we going to take that information to write an equation that's going to tell us the total spent? We're still using P and C, right? But now, Burgess?
15p plus 750 T or C equals 360.
Brilliant, right? $15 per person tube. If you buy one person tube, it's $15. You buy two of them, now it's 30. You buy three of them, 45. 10 of them, it's 150, right? You're multiplying the number of person tubes by $15. It's $15 per tube. And then plus 7.5C, because 750 per cooler tube. If you want to put the 7.50, it's fine, okay? But there you have it. There's our system. The process to solve this is the same as it was in the one above it, the same as it was in CO41 part 1. This is the new stuff here, setting this up. Okay? For next class, whether it be tomorrow or Thursday or Friday or who knows, next week, okay, I would just want you to finish this. I want you to practice more, not the whole objective, just this question. Okay? Practice with the solving piece of it. We've written the equations. Hopefully you're kind of seeing how that fits together. If not, we'll practice it more. But I do want you to go back and practice the solving piece, because even if you can set these up, this still is not your answer, right? You have to solve them out. Okay? So you can go continue with that. Anything that's being thrown back row, make sure it gets picked up before you leave. Okay? All right. That's how I meant. Like, subscribe, all the things.